Hello, gals and guys. Mr. Ambrose here, and this week we're going to continue examining the internet. In particular, today we're going to look at internet addresses. So, last week when we talked about and examined the internet, we saw that the main idea, the main purpose of the internet is to send information from one computer to the other. And we saw that, right, if we have this computer here with Mr. Smiley Face on it, and we want to send to this computer here, first this computer needs to connect to the internet and then find its way to the connection that this computer is making to the internet and then send the information over the internet using binary numbers, right? And so while, okay, we saw that last week, the question now perhaps is, right, how does this one computer here find exactly where this other computer perhaps is located over the internet, right? And so that's what we're going to see today. And that has to do with actual, internet addresses. So the internet addresses that are used to help find one computer find the other is very similar to how the postal service works and how we mail um, materials from one address to another one. And so in the postal mail, right, we have physical street addresses. And in the internet, we have what's referred to as internet addresses. So, because of the similarity between the post office addresses and internet addresses, let's actually take a look at how our postal address kind of works. And so we'll work off of perhaps this address here and all the information that we have here that helps us find exactly where this address is located on the planet, on our planet, on Earth. So we start with perhaps this first thing here, the USA address. And so on our planet, right, this USA tells us that, well, this address is located somewhere, right, in this part of the world. And then from there, right, this next line here tells us that, okay, within this entire United States of America, right, San Francisco in this zip code is located right over here on, in the United States. And so when we zoom in on that part of the United States in this particular zip code, right, now we are, honing in on exactly where this address is on the world. And then we can, within this zip code in San Francisco, right, we can look and find Mission Street, which is perhaps right over here. And so we're getting even closer to where this actual address is. And then from there, this number tells us exactly where the actual address is on Mission Street. And so we know exactly where this, this address is, you know, located on the entire world. Okay, and so this sort of hierarchy that we see here helps us identify exactly where this place is on planet Earth. And so internet addresses work in a very similar manner. Every device that's connected to the internet has a unique internet address. When data is sent from one computer to the other, there's a to address and a from address, just like you do when you perhaps mail a letter, out from your home to someone else's home. And the addresses follow a standard agreed upon format. And that particular format is what we call or refer to as the Internet Protocol. And the protocol will define exactly the layout of our internet addresses. And because of that, we refer to that as an IP address. And this term IP address you perhaps have heard of before. And so this here is an example of an IP address. And if you notice, there are these dots here that kind of separate this into four different numbers. And so this IP address is referred to as hierarchical because it sets up a hierarchy where one number is perhaps a subset or belonging to the other one. And if we look at this IP address in further detail, this first number, 93, within the whole internet, this first number here perhaps represents a grand or very big network within the internet. And so perhaps this network here represents a network comprising of a whole country. And then from there, the next number, 184, would be a subnetwork to this network here. So this number here perhaps represents a region within this network here. And then the next number after that would be a sub-subnetwork. This would be a subnetwork to this network here. And so this is getting closer perhaps to exactly where the device is located on the internet. And perhaps this sub-subnetwork is, just contains, a certain number of devices that contain ultimately the device that this whole address represents. And so the very last number here would represent the actual device that's located in this sub-subnetwork. And this is the actual device that's located on the internet. So this is, again, represented, it's an IP address that represents exactly where a device is located on the internet. So to see this perhaps in a more visual way, if let's say that this whole diagram here represents the entire internet, right? So all these are all the, perhaps devices located on the internet. Obviously, it's not big enough, but let's just assume that this represents the entire internet. And if we have, again, this IP address, if we start looking at, breaking this down, again, this first number represents, a certain network on the internet. So perhaps if this, again, is the whole internet, this tells us, well, this is, where our device is somewhere located on the entire network. And then from there, again, the next number, 184, that's the subnetwork, tells us that, okay, our device is located here within this bigger network. And then going down from there, the number 216 tells us that within this subnetwork, right, our device is located over here in this sub-subnetwork. And then within here, the 34 tells us that within that sub-subnetwork, right, this is where that device, this number 34 tells us this is exactly where that device is located, right? So this is how, your basic IP address kind of works and helping us identify exactly where the device is located on the internet. And this type of an IP address is what we refer to as scalable because it's easy to add more devices, more networks and devices onto the internet, right? If we want to add a device to the internet, right, we can just add a number over here. And if we want to add a network, to the internet, we could just perhaps just add a number here or a subnetwork here or here. All right, so again, this IP address is therefore scalable. Now, with our work with computers, we know that computers don't deal with these decimal numbers. We deal with binary numbers. And so each of these numbers here, I claim we can represent with 8 bits. And to kind of recall exactly how our binary numbers work, just a quick overview again of binary numbers. If you recall, if we have 8 bits, right, the first of those bits is representative of the ones, because that's 2 to the 0. And then the next bit after that is representative of the how many number 2's that we have, because that's 2 to the first power. And then the next bit after that represents the number of 4's, which is 2 squared. And then this, this pattern just continues, right? There's the number 8's, which is 2 cubed. There's the number of 16's, which is 2 to the 4th, and so on. So this binary number, which has 8 bits, because of the ones here, here, and here, this would mean that we would have one of these 2 to the 7's, or 128's. This number here would represent that we have one of these 2 to the 4ths, or 16's. And then this number here, this 1 here, would mean that we have one of these 2 to the 0's, or 1's. And so this binary number, which has 8 bits, would equal essentially 128, 116, and 1, which adds up to 144. And this binary number equals, in decimal, it equals 145. And if you recall, um, based upon the number of bits that we have, that would tell us exactly how many possible values that we can store in, using that many bits. Right? And starting with just one bit, right, there's only two possible values because we only have 0, 1. But as we increase the number of bits, if you recall, basically the number of possible values doubled, right? Because if we have 2 bits, we have 4 possible values because these are the 4 possible ways that we can arrange those 2 bits. And then when we moved up to 3 bits, right, we have 8 possible values, or 2 to the third, because with 3 bits, these are all the possible ways that we can represent 3 bits, and there are 8 values there. And again, every time we increase the number of bits, the number of possible values doubles. So when we get up to 8 bits, we have 2 to the 8 possible values, which 2 to the 8th is equal to 256 possible values. So getting back to our IP address, if each of these numbers is represented by 8 bits, then we have a total of 32 bits that are representing our IP address. All right, so again, this IP address is represented by 32 bits. And again, since 8 bits represent per number, right, 2 to the 8th is, again, 256 possible numbers. And that allows each of these numbers here, which are represented by 8 bits, to have the possibility to range from any decimal number ranging from 0 to 255. And because, again, this IP address is represented by 32 bits, that means that we have 2 to the 32 possible IP addresses, which 2 to the raised to the 32 power is over 4 billion. Right? And again, because 8 bits ranges from 0 to 255, right? The IP addresses that we possibly have can range from 0000 all the way to this IP address here. Now, when this IP address was originally established and set up, right, for over 4 billion possible IP addresses, well, that definitely was a lot of possible IP addresses. And this original version was the version IPv4. And this was set up back in the 80s. And while over 4 billion possible IP addresses is a lot of possibilities, in the 80s, again, that was considered, enough to satisfy IP addresses back then. Now, unfortunately, that's not enough. There's just the way the internet is growing, it's way too vast. And so this is not going to be sufficient. So because of that, there's a transition now to what we call the new version, IPv6. And this new version of establishing IP addresses will, in essence, have 100 or use 128 bits. And that's going to allow for a tremendous more number of IP addresses, right? Because if we have 128 bits, that means that we would have 2 to the 128th power possible IP addresses, which equates to this number here, which for now, that definitely should be enough for the foreseeable future. But perhaps way down the line, even this perhaps will need to be adjusted. But for now, this should definitely do. And so we're in the process of transitioning to this new IP address system. And so this here would represent a representative IP address under this IPv6 protocol. And if you notice in here, you notice perhaps not just the decimal digits, but you notice these digits here, D and B. And you might recognize that those digits are what we have within our hexadecimal system. And so if you recall hexadecimal numbers, there are 16 digits in the hexadecimal number system. And right, the digits range from 0 to 9, but that's only 10 digits. And if you recall, the remaining 6 digits in the hexadecimal number system are A, B, C, D, E, and F, where A is equal to 10 in decimal, and this ranges up to F, which is 15 in decimal. And so a hexadecimal digit can be calculated or converted into decimals in a similar manner to how we converted binary to decimals. So I won't belabor this here. We don't necessarily need this here for today. But because in the hexadecimal number system, there are 16 digits, we can represent any hexadecimal number using 4 bits. Because remember, in binary, the number of bits, the number of values that can be stored in there, if we have 4 bits, that would mean we would have 2 to the 4th number of possible values, and 2 to the 4th is equal to 16, which equates to the number of decimals we have in hexadecimal. So 0 in hexadecimal would be represented by this binary number, and F in hexadecimal, which is essentially 15, would be equal to this in hexadecimal. And so, right, every hexadecimal digit, right, this would be the binary number equivalent. And again, we only need 4 bits to represent any of these digits in hexadecimal. So getting back to this IP address in IPv6, if you notice, this IP address is broken up by these semicolons, and there are 1, 2, 3, 4, 5, 6, 7, 8 of this arrangement of 4-digit hexadecimal values. And so because of that, there are, if you look at this here, because there are 8 of these 4-digit hexadecimal values, that means that technically there are 32 of these hexadecimal digits. And remember that I just said that each hex value can be expressed using 4 bits. That would mean that's where we get these 128 bits, because again, there are 32 of these hexadecimal digits, and each hexadecimal digit can be represented by 4 bits. So that's the 128 bits, which means that, again, we can store 2 to the 128 possible IP addresses, which is a tremendous amount and should allow this IPv6 to be able to store all the IP addresses that we have over the internet. So it's pretty much the same structure, just more possible combinations. So the last thing for this particular lesson is something referred to as, well, who is deciding all these protocols? And I guess the community that's actually doing this is referred to as the Internet Engineering Task Force, or abbreviated as IETF. And this is an open community. These are people who voluntarily, work together to sort of set up these protocols. And this community involves engineers, designers, vendors, and researchers, and they're all have a common interest to make sure that the internet runs in a smooth fashion. And none of these people are getting paid. They meet, I believe, like 3 times a year to discuss exactly the protocols that we have on the internet, and perhaps any necessary adjustments that need to be made. And actually, it's something that if you want to explore, you can look into. And if one day you decide that you want to participate in this, technically, I guess you can, in contributing and participating in establishing the exact protocols that we have, to make sure that the internet runs in a smooth fashion. So that's pretty much this particular lesson on internet addresses. In this section, there are 2 quizzes and 2 exercises that I will ask for you to complete, and I will ask you to try to have these done by Friday of this week. So I hope this video helped you understand exactly how we deal with internet addresses and how one computer finds another over the internet. And if you have any questions, please let me know. And as always, please take care, stay safe, and I'll talk to you soon.